Okay, here we'll just do some examples using this formula. Okay, I've not rubbed it out because we're going to apply that now. Okay, but before I do, something maybe I could have mentioned in the last video but didn't. We're rotating it about the x-axis, remember, like that. Okay, what if you want to rotate it about the y-axis? That's doable. That's kind of the reason why I was doing like that, to show you it's an x-axis movement, and I never did that for the y-axis movement. Can you see how the formula will change if you rotate it about the y-axis? It'll be this, integral pi x squared dx. No, pi x squared dy. Okay, but I can't bother to reshoot the video. Yeah, slip of the tongue that was. So volume equals pi x squared dy. Okay, just going back to the previous video where I demonstrated why that formula works for you, or how we derived it. Okay, and instead just do it around the y-axis, and you finally get this. Okay. Anyway, moving on. And there's another formula that exists for the parametric equations as well, but you can look that up. Okay, I'm not about to do that now. I want to get straight into this example. The curve y equals sine x is rotated 2 pi radians about the x-axis between x is 0 and x equals pi. Find the volume of the solid formed. So I'm sure you can picture in your head what's going on, but a graph is always nice, isn't it? I think so. So between 0 and pi, that's what the graph of sine x looks like. Okay. Let's just put that in, because it's always nice to label the equation, isn't it? Okay, so that's why I've chosen the limits of 0 and pi, you see, because then you get a nice closed curve. You don't have to get a closed curve. I could have just done it between 0 and pi over 2, but that kind of looks nice. Then all of that is rotated around the x-axis, 2 pi radians. Doesn't quite give you a spherical ball, does it? Because it's a sine graph, okay, but it gives you something that approximates that, okay. Anyway, that gives you an idea of what you're looking at. We want to find the volume of what that 3D solid is going to be, okay. So the first thing you should do really is just either quote the formula or just substitute straight in. So its volume is pi y squared dx, where y is sine x. So sine squared x dx, and then put in the limits between 0 and pi. That is it. And that's the volume of revolution bit done. Okay, the rest is just integration. Okay, so it's just an application, really. This is just an application of using integration to find the volume. Okay, the exciting bit for me anyway starts here, where you actually get to integrate something. Okay, so we'll do that. Integral of pi sine squared x. I'm sure you can do that. I'm sure you can do that very quickly. 2 minutes. Okay. Yeah. Right. Race me if you want. 3, 2, 1, go. How did you do? I was quiet, so that didn't interfere with your thought processes as well. Okay. Right. That's kind of fun, wasn't it? Okay. Integration against the clock. Okay. I don't often do that. It's kind of fun to do. But anyway, I'm hoping you're happy with it. So yeah, I mean, cos squared x sine squared x. You got to use the identity with cos 2x. Okay. So 1 minus 2 sine squared x. So what I did, I just brought that to that side. And this to this side, and then just half it, so you've got sine squared x equals that, rather than just rewrite another line, because I was against the clock, I was against you. Okay, I just integrated that, so half x, and then this one there, yeah, so I've got a bit of a mental block. I don't know what it is. I've got a bit of a mental block on integrating expressions like that. I don't know why, I just can't write it down straight away. It's just, I've got a thought process has got to be there. I know it's going to be something sine 2x, but I've got to keep thinking about whether it's positive or negative, and then the half, and then divide by 2. Anyway, there we go. Okay, so right, hopefully we got to that. Okay, and let's just put this set of limits in, shall we? So you got pi, and then that's going to be half pi. So that's pi over 2, shall we? Sine 2 pi is 0. Great. and then we'll put 0 into that, 0, 0, oh, it's just that, isn't it? Okay, so pi squared over, why am I writing that? It looks nothing like 2, does it? Yeah, pi squared over 2. So yeah, that's it. That's your answer. Catch your volume. Is that okay? Good. I'll record a separate video for the next one.